Hi Year 11, I'm going to start talking to you about differentiating by first principles today. So we're going to have a look at how a curve is different to a straight line. So if I drew like a little section of a curve, and say I wanted to find the gradient of that curve, well, it's changing all the time. So the gradient here, for example, would be very different to the gradient here, and that would be different to the gradient there. So it's much more difficult than the gradient on a straight line. If I drew myself a chord between 2 points on that straight line, okay, and found the gradient, then you can see that there's quite a big difference there between those, the gradient of the curve and the gradient of that straight line. It's not really mirroring that straight line a lot. However, if I drew a chord that's a little bit smaller, where those 2 points were nearer together, the gradient of this chord would be much more similar to the gradient of the curve. Still not accurate by any means, but still a lot more similar. So what if I did my 2 points so close together that the difference was minuscule? Well, then my gradient would be even more accurate. And that's the principle of differentiation, okay, is that we're saying, what if we did a point on my curve and then we did another point that was so close to the other point that you would need like a microscope to have a look at the difference between them? What would my gradient be then? So we're going to have a look at that now and see how we can use that to calculate my gradients. Right, so we're going to imagine that I've got my microscope now and I've got these 2 points, my point A and my point B. Okay, and I'm going to say I've put this curve under a microscope and A and B are really, really, really close together. So my B coordinate is my A coordinate with a teeny tiny bit added on. So I'm going to use the graph of y is equal to, let's say, x squared plus 3x, just as an example. So I'm going to say, well, at A, my x coordinate would just be x, and my y coordinate would be x squared plus 3x, because my equation tells me that that's how I get my y coordinate. At B then, I'm adding just this tiny little bit to my x coordinate. So I can say my x coordinate is x plus dx, which is a teeny tiny change in x. And I can say that my y coordinate, well, instead of my x coordinate, I'm just going to substitute my new x plus this teeny tiny change in it. So I've got x plus dx, and according to my equation here, I'm going to square that, plus 3 lots of x plus dx. And they're my two coordinates. I've got my coordinate of A and my coordinate of B. Now I know that if I wanted to find my gradient, I would do the difference in y divided by the difference in x. So that's what I'm going to do to get my gradient. And we're going to call the difference in y dy and the difference in x dx. And I can see I've already used the difference in x here to say that my point B is x plus this teeny tiny difference in x. So my y coordinate is here. This is my y2 and this is my y1. So I'm going to use y2 is x plus dx squared, plus 3 lots of x plus dx, and I'm going to subtract my y1. Oh, that's annoying, I'm going to have to go around the corner. 3x squared plus 3x. I'm going to divide that in my difference in x's. So this is my x2 coordinate and this is my x1. So I'm going to divide that by x plus dx, y2 coordinate minus my y1 coordinate, which is just x. And I'm going to simplify that out and expand my brackets. So when I do that, I've got dy by dx equals, so my first bracket I'm going to expand is here. Okay, so I'm going to square that bracket. When I square that bracket, I'm going to get x squared plus 2 lots of x dx, because I'm multiplying that by x, and then I'm going to also do it when I'm multiplying the second bracket, plus dx squared. And then I'm going to multiply this bracket out. So I've got 3 times x plus 3 times dx. And I'm subtracting all of this. Now I'm going to put that in brackets because otherwise you might think I'm adding the 3x, but actually I'm taking the whole lot of it away. So I'm taking away x squared plus 3x. I'm taking all of that away. And underneath I've got x plus dx minus x. So those x minus x can cancel each other out. And that just becomes dx. I can still simplify the top row here, so I'm just going to simplify that now. Just bear with me, I'll just zoom in. Oh no, I won't because it goes off. There we go. Okay, so what I've got there is my x squared here, but I'm going to take away an x squared there. So these two will cancel each other out. And you'll always find that your first term will always cancel out. Then I've got my 2x dx. Have I got anything else with an x and dx? No. So I could just write that in. I've got 2x dx. Then I've got my dx squared. Again, that's on its own. Okay, when I go on to the next bit, I've got 3x here. Take away my 3x there. So they're going to cancel each other out. And all I've got left then is plus 3 dx. And that's all going to be divided by dx. So the next thing that I'm going to do is divide by the dx. When I divide 2x dx by dx, I get 2x. When I divide dx squared by dx, I get dx. And when I divide 3 dx by dx, I get 3. So my dy by dx at this point is 2x plus dx plus 3. Now, we're talking about dx being this teeny tiny little difference. And now I'm going to think about the limits of that difference. So the difference couldn't be 0, because if it was 0, I would have nothing on the bottom there. And I can't divide into nothing. That's essentially saying that it just disappears. So it can't get to nothing, but it can get as close to nothing as we can get. So we would write that as limit. So that's my limit. As dx tends to 0, dy by dx is going to equal. Okay, so the limit tells me that it's limited at 0. It can't get as far as 0, but as it tends towards 0, what happens when dx gets so close to 0? Well, my dy by dx becomes just dx plus 3, because the dx would be so minuscule that it wouldn't matter. And that would be my differentiated answer. So I've got my original sum here is x squared plus 3x. And then when I've differentiated it, my answer has come out as 2x plus 3 as dx tends to 0. Now that is a really long way around differentiating, and I am going to show you a quicker way around it, but you need to know where it's come from, and so you will be asked on your assessment to differentiate something by first principles, just showing that you're understanding where it's come from, that it's come from the gradient. I'm going to do one more example for you on the next slide, okay?